Cumulative incidence is the number of new cases in a given population during a specified period of time divided by the number of disease-free individuals at the risk at the beginning of that period. To understand cumulative incidence, let's imagine a fictitious situation. Imagine you are a healthcare professional traveling on a cruise ship, enjoying the horizon and the sea view, when suddenly you hear an announcement from the cruise team that someone is not feeling well and needs medical attention. You examine the patient and suspect that they have chickenpox, and the next day another patient shows up with the same symptoms, and then the day after that another patient shows up with the same symptoms. Say there are 30 guests on the ship and it will take 15 days to reach the destination. During those 15 days, no one leaves the ship and no one boards the ship. In this situation, cumulative incidence is the most appropriate measure because this is a typical example of a closed population. A closed population is a population in which no one enters or no one leaves during the study period. Let's assume this is our cruise ship and these are our 30 guests. We follow all of them for the entire 15-day period because no one enters or leaves the ship. The population remains fixed throughout the study. During this period, we observe the transition of disease-free individuals to the disease state, which is in this example is chickenpox. At the beginning of the study, everyone is susceptible to chickenpox and capable of developing the disease. Cumulative incidence expresses the risk of contracting an illness in a given population with a fixed period of time. So what is risk? Risk is the probability of a negative or undesirable event occurring. It exists whenever uncertainty is involved. For example, there is always a risk of falling when the floor is wet, but you can't predict the exact outcome. It might result in a minor stumble or a severe injury, such as a fracture. Similarly, in our cruise ship example, there is a risk that you may also contract chickenpox. Note that in this example, we are assuming that everyone on the cruise ship is susceptible to the infection and at risk of developing the chickenpox. No one is vaccinated and no one has prior immunity to the disease. Therefore, cumulative incidence measures the risk of developing chickenpox during the 15-day voyage. Cumulative incidence is typically used when the cohort being followed is fixed and all participants can be followed throughout the study period. Let's look at another example. Suppose we have five individuals, these five individuals admitted to a surgical ward for the treatment of fractures. We follow them for 5 days to determine how many develop a nosocomial infection, which is a hospital-acquired infection, and our event of interest. The population is fixed, consisting of 5 individuals, and the follow-up period is also fixed at 5 days. Suppose these 3 individuals remain healthy throughout the study period, while these 2 develop a nosocomial infection. In cumulative incidence, it doesn't matter exactly when the infection occurred during the 5-day period. The infection could have occurred on day 1 or day 3 or day 5. We are interested only in whether the individual became a new case during the study period. In other words, we observe the population at the beginning of the study to confirm that everyone is disease-free and then determine how many individuals develop the disease during the follow-up. In this example, 2 individuals developed a nosocomial infection, so the numerator is 2. The denominator is 5, representing the disease-free individuals who were at the risk at the beginning of the study. Therefore, cumulative incidence is 2 divided by 5, which is 0.4 or 40%. This means that the risk of developing a nosocomial infection during the 5-day period is 40%. Here the numerator is subset of the denominator. That's why cumulative incidence is a proportion. It can take values between 0 and 1 or between 0% and 100%. A cumulative incidence of 0% means that no one developed the disease, whereas a cumulative incidence of 100% means that everyone developed the disease during the study period. To calculate cumulative incidence, participants should ideally be observed until either the end of the study period or the onset of disease, whichever comes first. One important assumption is that the population remains fixed and that participants can be followed throughout the study period. However, in real-world situations, this is often not the case. Many studies involve dynamic or open populations in which individuals may enter or leave the study at different times. For example, participants may move away, stop attending follow-up visits, or withdraw from the study, or die from other causes which are unrelated to the disease which is being studied. Imagine that this participant leaves the hospital and becomes impossible to trace. In that case, you don't know whether they developed the disease later in life, remained healthy, or died from another cause. This situation is known as censoring. Another situation here is that this person died due to severity of injuries, so could not be followed up further. The person died, but not due to the disease which we are interested in, that is nosocomial infection. This other cause is called competing risk. In fact, everyone in the study group had the risk of developing other diseases or die from other causes. Because cumulative incidence assumes complete follow-up, it becomes less suitable when censoring or competing risks are common. In these kind of scenarios, cumulative incidence is not a typical choice of measuring risk. So here comes the incidence rate. Incidence rate allows the participants to leave or enter the study at any time. There is no fixed time period or fixed population. Another important point about cumulative incidence is that it focuses on the first occurrence of an event during a specified period of time or study. For many diseases, once an individual develops the disease, they are no longer considered at risk of becoming a new case during that period. For example, HIV, diabetes, or rabies. However, some diseases can occur more than once in the same individual. For example, a person may experience multiple episodes of influenza or recurrent infections. In cumulative incidence, we only count the first occurrence of the event. When recurrent events are common, incidence rate is the more appropriate choice to measure the risk, to avoid any bias in estimates, because it can account for varying follow-up times and multiple events occurring in the same individuals. It can handle the issue of dynamic population and multiple episodes of the same disease in the same individual. We will discuss incidence rate in the next video. Thank you for watching and see you then. Bye.